Hello and welcome everyone. Happy Tuesday. We're really glad to have you here for our next session in the Day 1 and Beyond series, which takes you through various topics and activities related to building out an Oracle Cloud. For anyone who might be new to these events, welcome. We are hosted on Cloud Customer Connect, which is our Oracle Community Forum for end users. We should have a poll on the screen now, Mike, if we can get the poll going. This is to just get an understanding of everyone's level of experience with cloud and Oracle Cloud infrastructure. This helps us in customizing our content for the upcoming session. So would really appreciate if you take a second to respond to this poll. This session is being recorded and you'll be able to find the recording on Cloud Customer Connect. You can find the recordings and the slide deck PDFs of our previous sessions as well over there on that site. And you'll get an email after this session with the right links to access the recordings. I'm Renu Bhatt, a TPM with the Customer Enablement team. And today I'm joined by Anand Prasad, Cloud Architect, Len Lois, Senior Cloud Engineer here at Oracle. And joining us as an OCI expert today is Jason Cook. He's Master Principal Cloud Architect. Like always, a quick reminder to use the Q&A box down at the bottom of the screen for any questions throughout the session. If you put the questions in chat, I would request you to move that to the Q&A panel. Today, we are going to cover networking quick start on OCI. Anand and Len, let's dive in.
Well, thank you, Renu. If you'd give me the next slide. So you can see this is our agenda. We're going to cover the virtual cloud network. That's what Oracle refers to as our software-defined network. We're going to talk about gateways, which is just our term for routers. So, and think of whenever you see the term gateway inside OCI, think of them simply as an embedded Linux box with capabilities to direct traffic director, if you will. And then our security processes that we put in place to keep you secure. And then we're going to talk a little bit about load balancers and then also fast connect. At any time, do go ahead and put your questions in the chat. So the key to the technology that all of the open cloud developers have brought to you is the virtual cloud network. And as you can see, in this slide, you have the core infrastructure, which is compute, containers, storage, and then the networking connects that all together. And then on your right-hand side, you have governance and administration, and on the left-hand side, you have developer services. But built into this, the only way you can get to any of this is through having your network set up and set up properly. Next slide. So behind the scenes, I want to make sure you understand that a little bit about the physical qualities that we provide for you. So you have 3 data centers in every region. The data centers are between 50 and 80 kilometers apart, and they're very performant, low latency, high speed interconnect between the hosts in an AD. So all the little boxes in it. Next slide. Next slide, Anand. There you go. So if you see where it says physical network, that's where you know that each of the boxes in the rack have 2 intelligent NICs, and they're a minimum of 25 gigabits each. In addition, the top of rack box, what used to be called the top of racks box, again, the router, if you will, it's just a Linux box with a lot of connectivity. And those 2 are intelligent NICs. And we actually use 2 dome zeros in that router, if you will, that gateway. And one controls all those virtual NICs as part of the virtual network. And the other has a dome zero for all the virtual machines and the containers and the rest of what's there. So you have a really tight control over, we have really tight control over the data and how it's moving, and have given you a very performant capability. Next slide.
Lynn, before you jump into the next slide, I want to ask Jason a particular comment. Jason, based on your experience, can you comment on how does this physical network and virtual network play a role in the networking side of the fence from your side? Like, what is the performance side of the fence we can talk about from OCI angle?
Yeah, absolutely. I mean, that's a good question. As customers are figuring out how to lay out their workloads, right? One of the things that commonly comes up is how do I build resiliency in the way of HA and DR? And even how do I connect to other clouds? So briefly, what I'd say to those 3 points is, customers rest assured that if they take their workloads and build them out across multiple availability domains, and again, from what Lynn was saying, think of that as multiple data centers. We have very, very high-speed connectivity between all of those individual data centers, a lot of redundancy that can ride out multiple different kind of hardware failures. And that, overall, you can build a very highly available solution simply by just putting your workloads across more than one availability domain, more than one data center, right? And that takes care of a lot of the HA story. For DR, a lot of our customers, the ones I work with, look at using an alternate region. Maybe their production in our Ashburn region, and they look at DR, maybe Phoenix. And between those regions, we provide high-speed connectivity so that they can do things like data replication, that they can transfer images over, they can run active-active, active-passive, they can run in multiple different DR scenarios to provide them quick failover, quick data transfer as they're doing, say, database replication, and that they can quickly do a failover. Customers I've worked with can fail environments over, I've seen as fast as a few minutes, and even large workloads in less than a half hour. And then for the customers that are doing multi-cloud, right? You've got a workload on something like Azure. We've got an interconnect that provides high-speed connectivity from apps on Azure and those on OCI with less than 2 milliseconds of latency so that you have a very performant connection to something that is multi-cloud.
Thank you, Jason. Lynn, back to you.
Thank you. And on this slide, what we're looking at, and the point of it, if you will, is that networking truly is key to your security as well. It's going to give you security at the edge with global points of presence, denial of service protection, as well as protection from different, I'll get it out, different territories through DNS, traffic management. So all this is going to be one guard. Internally, you're going to have your virtual cloud network, your private subnets, your capability to have bastions, if you will, as well as the different types of routers, the different gateways that we're going to talk about. And fundamentally, everything is encrypted in motion, both internally and externally. Next slide. So we sort of foreshadowed a lot of this, but essentially you have a fully configurable system with subnets, routing, firewalls. You have multiple ways of getting in, either through direct connect or VPN. You have load balancers, both north and south, outside of the edge, as well as internally, and you can choose to judge the health of your backend servers, either through multiple methodologies that are listed there. Your service gateway is a nice little trick. It's simply a private access without traversing the internet. You don't have to go out into the wild, wild east, if you will, to get to your data, whether it be in a data system or in a storage system. You can connect directly through the service gateway or the storage gateway, for that matter. And then it works very well connecting on-prem as well as to Oracle Cloud Network and to other public networks as well. Next slide. All right, so this is a typical display or diagram of what a software-defined network looks like, a virtual cloud network, if you will. And you have an AD, which is an availability domain, which is a data center inside a region. And you have the virtual cloud network that encompasses usually more than one AD, but it can only be in one AD. Likewise, the smaller boxes there are simply depictions of subnets. Next slide, if you will, or connect. And next one, that stop there. No, oh, back one. Sorry. So the idea is that in the subnets can be either on one availability domain or across boundaries as well. And you typically would have at least one connection to your data center and one connection to the internet. The one to the internet's not required, but the one to your data center certainly is. Next slide. Go ahead and hit a couple more there. Yes, that's it. And we use the current masking CIDR block methodology of looking at this. And if you know how to work with it, and it's not hard, there's like a multiple things on the internet will tell you what this means, right? So it's not difficult if you see it once, but it's different than the old masking, if you will. And these examples I'm going to show you are 32-bit. We do support VPN 6 as well, so we do support 64-bit as well. So if you do want to connect to all the hydrogen atoms in the visible universe, then you can go to IPv6. But most folks are satisfied, at least internally, unless they're not using internet or clouds, or they're providing telephone service somewhere in the world, you can get away with just 32 bits. In this particular one, the typical VCN default is /16, which gives you 65,000 plus or minus IP addresses. Likewise, with 24, that's about 256 IP addresses in those circumstances. So usually that's adequate for most folks. And any comments there, Jason, on that?
From this one here, I think the biggest takeaway I'd have from VCN address space is think into the future as far as you can. Get your crystal ball out and try to predict what you'll need for your address space, at least minimally a year out. Potentially a couple. I mean, not so big that you'll use up all the IP space that you have internally, but enough that you're not having to constantly go back and readjust all your VCNs for the workloads you're going to be hosting there and the expandability that they may have.
Thank you, Jason.
As much as anything else, next slide. Go ahead. So in your subnets or anything else you do, you've got to remember that this is software. So just like in your when you're writing software, you have to tell the machine everything, otherwise it doesn't know anything, right? So one of the aspects of your virtual network is to have a route table, so you're telling it where the next leap is. So it consists of a set of rules, and each rule specifies the destination CIDR block and the route target that matches the next hop. So in this case, you have the destination of the internet, that'd be where you have a /0, right? The known universe. And you're going through a NAT, which is a mask in such a way that you can talk to it from inside, go out and go to the internet, and then the internet can't see anything but the address of that NAT gateway. It can't see anything that's inside your tenancy at all. So, but you can see the description, it just goes out to the network. Typically you'd use it for patching and that type of thing, where you have to go to a repository outside. Or in the next thing, you have a service gateway. And this one, you see, it just goes, okay, that's fine, Anand. That's good. That's good. No, I can talk to that. So anyway, the point being is it's soft. The point of this is really, it's just software. Next slide. Go ahead and complete the slide. One more couple till it says use case. Yeah, so again, that's where we were talking about with the NAT gateway, as I mentioned. And then here is an example where you'd have a private subnet. Notice that it only talks to your home base and through the NAT gateway. And then you have a public one. By definition, that's going to be back and forth to the internet, and it goes through your internet gateway. Again, just a specialized router. Excuse me. Next slide. So in the specialized router, in this case, is your DRG, and it is just talks to your CPE. We'll just throw in a couple more acronyms. Right? So your DRG talks to your router at base. So it has a specific connection either through IPsec, VPN, or through Fast Connect to your data center. Doesn't go anywhere else. Next slide. Again, this is an example of the service gateway, as I mentioned before, and this allows you usually inside your regions to go through multiple services, multiple ADs, and it stays inside your region. So it keeps all the traffic inside, so you can, great place to put things together for access from your private I'll get it out, your private subnet to your autonomous database, or from your autonomous database to your object storage for your backups and recovery. So those are the types of things that way you're never exposed to go through the internet to get back and forth. Next slide. Another trick to think about with respect to, now that you're in OCI and you're working with multiple regions perhaps, and certainly multiple virtual cloud networks, perhaps one group in your organization has one virtual cloud network, the other one has another in there. So again, we provide specific kinds of routers, local peering gateway, if you're within the region, back and forth, and then you can do remote peering through multiple DRGs that are going to be talking back and forth. This is the only time that you would be working with a DRG that wouldn't go to your your local, I'll get it out, your local data center. So this is, now you're not talking to your CPE, you're talking to another DRG in another region. Next slide. And I think, I think this is yours, isn't it?
Yes, I'll take it from here. Thank you, Lynn. Thank you. So, folks, I think I know we are introducing a lot of terminologies here from a networking perspective. This is definitely a technical deep dive session, or technical session, so that we'll introduce a lot of topics. But from a security perspective, like, as Jason was talking about earlier, right? What does, software-defined networking provides you? It provides you a segmentation. And how do you segment it? How do you control the traffic is what I'm going to talk about from a security perspective. From security angle, if you can look at it from a VCN perspective, we are not controlling the north-south traffic here. Usually the north-south traffic is controlled at the firewalls, whether it's Cisco, Miraki's, or Palo Alto's. We are talking about specifically east-west traffic. So the traffic coming into the VCN, and how are you going to control the traffic, whether it is between the subnets or within the subnets, okay? So there is two capabilities OCI provides you. Is one of the capability is known as security list, which provides you at the subnet level. The advantages of that is it's a blanket policies, firewall rules. You can set it up so that you can set ingress rules and egress rules for that the subnet level. Now, there is definitely a requirements for you where basically you want to tighter control it. You deploy multiple capabilities or applications inside this subnet, and you want to have a granular control. And that's what we provide you at a network security group, which is at the VNIC level. So if the traffic is coming into the VCN and you want to control the traffic within the VCN, there is two choices for you to do it. One is the security list, the other one is network security group. Now, we definitely do not recommend to have a duplicate controls. A lot of seen implementation where they have a security list as well as network security list where they control the same egress rules in duplicate controls. We want to have use the security list for broader control, use the network security groups for a very tighter control. As you can see in this example, which I'm showing you on the screen, the second right-hand example is from the network security groups, which controls at the VNIC level, very granular control. Pretty sure you have a lot of applications which is deployed, which needs very, very controlled, capabilities. So we provide you network security group for that. Okay. Now that leads into the one more question, which I want to bring in Jason on. like Jason, what does a segmentation perspective from an industry, like, why does the flat networks is more dangerous to the security perspective? What does the segmentation provides you, and how deep the segmentation has been done, and what is the disadvantages of doing, like, different types of segmentation they do it, like, hub and spoke model. There's a lot of ways they do the segmentation. What is your thoughts on it from a segmentation perspective?
This is a really good question. It mirrors one of the questions that was asked earlier in our call today. In my mind, segmentation is going to address two major concerns from the customer, right? The first one's going to be blast radius isolation, right? Your network team is going to need to come in once in a while and make changes to the network, routing, firewall, and that blast radius isolation will help you make sure that when a change needs to be made, whether it's network or even something else, that if something goes wrong, something breaks, the change was done wrong, that it doesn't take out all of your applications at once, right? It doesn't take out your HR, your finance, your warehouse. The change is isolated to a specific segment or a subnet or a VCN, so it doesn't blow everything up. The second part, and this is kind of mirroring that, is from a security standpoint, right? Different workloads are going to have different application requirements, such as the ports that they need to connect to. Some are going to, just need something as simple as HTTPS access, and they may not need to, open up access to things like SSH. And so from a security standpoint, segmentation also allows you to be very specific with your security list, with your network security groups, even with your routing tables, to make sure that the kinds of traffic that you would expect to go to that workload are the only ones that are open, and that you've not put all your workloads in a single segment. Again, that could be a VCN, it could be a subnet, making you open up the ports to lots of things that are unnecessary. So segmentation is good for blast radius isolation, for changes. It's also good for your network security protocol, kind of as your border on your network and how you control it and what's supposed to go to your workloads.
Thank you, Jason. That leads to the next topic, which I'm going to talk about. It is like, load balancer. Like, so I know that in a cloud world, load balancer is one of the very popular deployments front-ending any web applications. Like, people use load balancers for many, many reasons. I think we encourage load balancers to use for service discovery. You can also provides you health check. And some of the key benefits the load balancer provides you is, like, right out of the bat is the HA capability, right? You can completely abstract the backend so that you don't have to expose it to the external world. And also as Jason was talking about isolation, right? Load balancer provides you a complete isolation from the backend. So you can always deploy the load balancer in the public subnet, and every backends can be in a private subnet, so that the attack perimeter from the external world is very, very reduced right now. And if you front end with a WAF, with a load balancer, you take out a lot of this security threats coming into your network environment. Okay, so a naming abstraction, I talked about it. I'll also show you a quick demo in the load balancer after this slide deck, so you can see that why load balance is such a key capability for all the web applications deployed on the cloud right now. Now, by default, as I talked, load balancer comes with HA. In our OCI also, we provide you the listener, which is as a primary listener and a failover listener. Although you don't see the failover listener, it is there behind the screens, and the failover happens, it automatically switches. The load balancer backends are automatically deployed across the 2 availability domains by minimum, so that it provides you an HA capability. Not that availability domains goes down so often, but in the cloud world, whether it is any Oracle or any other cloud vendor, but I think it is by default designed for taking care of in no single point of failure. Last but the least, I think from a load balancer perspective, health check is the key thing which provides you being proactive, servicing your customers at the highest level. So if you have an SLA where you do not want the production down issues, I think health check provides you being proactive. It takes off from the servicing the incoming request, so that the customers don't see the failed backend server. So it automatically, and if you attach an auto scaling to the load balancers, it is state of the art, so that when the servers goes down, it automatically brings up the new server into the template and deploys it, so that minimum number of servers is automatically there in the backend pool. Okay. Now, like every web applications also requires, like in a domain name service, Oracle also offers you highly scalable domain name system. If you're already using existing one, we encourage we allow you to import a lot of your zones records as well. We also provide you a lot of SDKs and APIs, so that you can create programmatically domain name service records as well as zones. So you can manage all those things. So it is highly scalable and with a low latency for you for the domain name service, which are the two key criteria for any domain name service. Now, from a traffic management system, I'll again tee off a question to Jason after this slide. From a traffic management system, right, you have a lot of capabilities from an OCI perspective, whether you want to use an active failover like sort of like a design where you have an active deployment in one of the regions and a failover deployment in other region. And when something goes down, it automatically switches to the failover. You can also provide you different backends closer to your customer's proximity. Let's say you have a global deployment, whether it's US, Europe, APAC, and you want to have a deployment where the customer's incoming customer request goes to a particular location. You can certainly use that geolocation steering so that a European deployment goes to all the European customers as well as APAC goes to so you reduce the network latency, okay? Now, the last two is like, based on the ASN number as well as IP prefix steering. Before I jump into the Fast Connect, I want to ask Jason one more very, very broadly industry popular question. Jason, what is the use of this traffic management? Like, when you're for global customers, how can they take advantage of a traffic management policies, whether, and how does OCI provides them the capabilities, which I talked about here?
Yeah, that's a good question. Oftentimes, this is going to come to the user experience that you're trying to provide your customers. So think of if you've got like an e-com application that provides more custom user experiences in each region, whether that's you automatically switch the language over to that local region, or maybe you just host products that are more relevant to Europe versus a USA-based market. What traffic steering is going to help you do is as customers come to your e-com site or any other site that is going to be more regionally focused, it's going to make sure those customers are being routed to the region with the right, front end for them. So if you've got a European customer base, you've got products that are going to be more appealing to that area, the traffic management is going to help get them to the part of, say, your e-com site that is meant for them. Versus if it's more of a US-based customer, again, those customers be routed to those sites, that content that's going to be more relevant to that kind of audience. So generally, that's one of the more common use cases I see is I want to make sure my customers have the best user experience possible. And traffic management with things like geo steering is going to make sure each customer base is going to get to the right part of your site and get the best possible customer experience for them.
Thank you, Jason. Now, moving on to the last part of the section, which is the connectivity options, like, OCI provides a lot more capabilities. Like, you have public reserved IP address, so you can bring your IPs. We provide you the ephemeral IPs as well. You can connect using the VPN, like, IPsec authentication. We have two main options we provide you. One is the OCI managed VPN service, which means we take care of all the completely, it's a managed service for you, or you can bring your software, the VPN, and run it on OCI compute. You can certainly do that. Now, in terms of Fast Connect, which is a very popular connectivity from your on-prem world to OCI, we provide you an SLAs, which is very, very critical when you want to connect when you want to expand your on-prem network to the cloud and make it feel like it's an expanded, data center. You need to have a connectivity, and the Fast Connect provides you that SLAs of port speeds of 1 Gbps and 10 Gbps. Okay. Now, the other two, conversations which I wanted to talk about it before I jump into the demo is Fast Connect also provides you a lot more options for you, whether it's a public peering connecting from your on-prem data center to the public services in OCI, or the private peering where you are connecting from your on-prem data center to your VCN in the OCI. Okay, you can certainly use both use cases. And as you can see on the diagram, we showcase both the use cases, one going into the object storage, another going through your VCN, which is in OCI. Okay. I know there's a lot of questions on the questions, which I think my colleagues will take a look at it. If you have any questions, we'll tee up on the questions while I switch into the demo world and showcase you how to create a VCN, how easy OCI provides you to create a wizard to create a VCN, and then I'll jump into the load balancing demo. Okay. Okay, I've logged into the Oracle console. Okay, And I'm pretty sure most of you have used Oracle OCI console. This is a very familiar console, which you can say it. For folks who haven't played around with OCI, this is the console which most people land in. And on the left-hand side, you can see that the Hamburgerman provides you a lot of the services which we offer it from a core infrastructure perspective. We have compute, storage, networking, database. I'm going to dive into the specifically focused on the networking side of the fence today. And then I think you also have Lynn talked about the breadth of the services which we have in OCI, analytics, AI, developer services, identity and security, and a lot more things we have it. Please check it out at your leisure. But I'm going to focus on networking for today's conversation. Okay. From a networking perspective, you can see that the virtual cloud network, we talked about it. And this is the cloud network, which I think creates your software-defined networking. We have other capabilities, like you can see it. I didn't touch upon everything in today's conversation with the interest of time. So we do have network command center. We do have a lot more customer connectivity as well. And then I think web application firewall, I didn't touch upon it today. In the virtual cloud network, what you can do is you can quickly use a wizard. I'll go into the So in the the compartment I choose, as you can see that I choose a compartment. I was at the root compartment. It showed me all the VCNs created for every one of us, was part of this tenancy. I'm going to specifically focus on this particular compartment, which is assigned to the session. And I'll start using the wizard right now. The wizard is very, very simple for folks who do not understand software-defined networking, to the people who have used software-defined networking before. It caters to all of those users, and it creates the software-defined networking in very, very quickly and very in a easy terms. I'll click Start Wizard, and you can name it it just needs a name of the software-defined networking. I'll call it day 1 and beyond. This is our session from OCI. And then I think it asks you, where do you want to create in the compartment structure? I have to mention a little bit about compartment structure in OCI. This is one of the key and unique offering compared to other cloud vendors. The closest you can get this compartment structure is in Google Cloud, which is the folders options. Okay. Now, the compartments is nothing but a logical separation in single tenancy. This is one of the key feature from OCI, which allows you to service multiple customers, service multiple teams, and you can attach every policies you can based on that particular compartment. Think about this as a Windows folder. You can go 6 levels down. So I've created a compartment called customers, and I'm going to create a VCN in that particular compartment. Now, in the cloud world, you can only go up to /16s. In the on-prem world, you can go up to /8s. Okay. Now you can see that I'm taking defaults here. For the public subnet, I also take /24. I don't need /24 in public subnet because we normally encourage people not to deploy many things in public subnet, only deploy everything in private subnet. So I'll make it /28. You can certainly change that. Now in private subnet, I'm going to take the default /24, and then I can also tag it. Tagging is one of the key feature which we normally encourage. Everything which you create, you tag it so that you can come back and search on the tag namespaces, manage the resources better on the cloud. By the way, I want to make a statement. Cloud is not cheap if you don't manage it well. Okay. So I want to make sure you tag it. I will also tag it I have already a tag, I have a Vision Corp, which is our a fictitious company, which we use it. And you can see that you can also have a drop down. It's a dev test, this one type. I'll use it dev as a default. And as you can see, if I click next, it showcases the summary of it. This discusses all the things we talked about it. As Lynn talked about gateways, which is nothing but the routers. For the public subnet, we have internet gateway. For private subnet, we have NAT gateway. We have service gateway, which I'll showcase all the things when it gets created. We talked about security list. We talked about route tables today. And then if I click create, it takes less than 30 seconds to create this. And I'm not joking it. I've timed it many times, and you can see that it takes less than 30 seconds. And then once it gets created, it's already created now. And then you can see this, the VCN here, it created with two subnets. One of them is private subnet and one is public subnet. And you can see that the route tables, which I talked about, I'll tee off a question to Jason in a minute right now on the route tables, right? Right now here is like, it has got a private subnet route table. By default, route table is used for the public subnet. Now in private subnet, if you can see that route table, which the example, which we also showed in the slide deck, it goes into the NAT gateway, and it also has an access to the service gateway. And this is one of the things, like, the service gateway provides you the advantages of, like, you going over the Oracle backbone. So let me ask a question to Jason before I jump into the other side of the VCN and the load balancer demo. Jason, from your experience in the industry, right? Does every software-defined networking has an access to the internet, or do they have an hub and spokes model where they have a transit VCN where every incoming request comes in, and then all the VCNs connect to the transit gateway, and then from the transit gateway, the firewall is inspected and the traffic is inspected in the firewall and it goes out? What is your take on, like, designing the VCNs, and then how is the route going into the external world?
Yeah, that's a good question, a complex one. So let me do my best to try to simplify it here and not take over the whole meeting with that explanation. A hub and spoke model is one of the more popular approaches I see customers use. And if you're not familiar with that, it's the basic concept of this. In a hub VCN, you would normally put a lot of your network and security infrastructure. So think of things like, where do I actually terminate my fast connect from my on-premise? Where would I want to provide egress out to the internet through like a Palo Alto firewall, so that customers can get out for patches or bring traffic in? Where would I put my security toolage so I can scan, patch, do vulnerability analysis? All that infrastructure oftentimes would be in your hub. Now, your spoke networks are going to be oftentimes where you actually have your real customer workloads. So think of, again, taking our ecom application, right? You would have your ecom stacks, their websites, the databases, all sitting in a spoke. And connectivity to that spoke would all be done through the hub. So if you, as an admin, needed to SSH in, you would go over your Fast Connect, you would go through your hub VCN, you might go over a local peering connection or another DRG connection to your spoke and get to your ecom app. Same thing for your customers. If customer needed to get to the ecom stack, they would likely come in through your hub, through your Palo Alto firewall, through any kind of security inspection toolage, and then be routed to the spoke. So any of your routing, any of your connectivity, any of your infrastructure, especially network and security, is going to be your hub. Any of your custom workloads are going to be in your spoke, and everything is going to flow through the hub, whether it's on-premise, to the internet, or to spoke connections. That's the most popular network design I see in the field.
Thank you, Jason. So continuing on this, I'll quickly touch upon this security list of it, and then I'll jump into the load balancer demo. So when I talked about it, security list is I want to show you quickly the security list for the private subnet, where what we do is if you can look at it, there is the only access to the private subnet is from the VCN itself, from the port 22 for SSH traffic. You can deploy a bastion host in a public subnet and access it only there. Everything else is blocked. Egress is only going out to the outside world. All the traffic are allowed. Similarly, there is a security list attached to the public subnet, which I don't want to go into that right now, and jump into the load balancer side of the fence. Okay. Now, I touched upon the load balancer. Okay. I've already created a load balancer for you. I'll walk you through creating a load balancer. It's a very, very simple process, but I've already created a load balancer for you and also deployed a sample a web HTML pages to both the web backend server, so you can see the demo. Now, creating a load balancer, as I said, is very, very simple. You can choose the application load balancer or the network load balancer, because this is layer 4 versus layer 7. And then you can see that, if you can click a load balancer here, it asks you the many details. I'll take a default right now with the name of the load balancer, whether it's a public load balancer, private load balancer. You want to have a reserved IP address versus ephemeral. I always encourage load balancer to be reserved IP address. Okay. Now, in terms of flexible shapes, one of the advantages of load balancers we offer right now is you don't have to think about what is the load coming in, because it's a flexible shape is definitely is the way to go, because your minimum bandwidth can be maybe like, you can say 100, start off with 100, and maximum you can choose anything you want. Like, you can say 800, like, depending upon the bandwidth. Okay. And this is where I think you can certainly do that, choose the minimum and maximum bandwidth. And then in terms of VCN, which is the VCN you want to deploy the load balancer, I've created a day one and beyond here. I'm choosing that. Okay. And in the subnet, I'm choosing the public subnet, since I choose the public load balancer. Okay. It automatically checks for you that if you're choosing a private load balancer, it automatically will display me the private subnet here. Okay. And that's it. Like, if you click on next, and then I think you have an algorithm which you want to use, IP hash or a round robin. And I use a round robin for easy simplicity, and you can add many backends to it. Now, like each backend, you can, if you have a global deployment, you can have a backend, based on languages. You can certainly do that. You can have multiple backends, and then the health check policy. I want to spend a little bit on the health check policies. I'll create a backend is like, if look at it, there's nothing backend service. I need to create a compute instance to have the backend service to be created. Now, I'll show you, I've already done that. Now, in the health check, I want to talk about a little bit on the health check here. Okay. Now, the health check is like, provides you a capability to be very, very proactive. What it does is it automatically polls the backend servers at a frequency, like, here it's 10,000, you can reduce it to 2,000. And then it makes sure it tries number of times so that it can mark it like, this instance is not available for servicing. And it does automatically, no human interaction is needed. Okay. Now, and then the reason it does is that I've given it like, you cannot have the interval less than the timeout. So I made it 2000 milliseconds, and then 1500 for the timeout. And the number of times I can reduce it to 2 times. This all is driven from your business requirements, right? What is the SLA you want to provide it to your customer? What is your business requirement? What is the minimum time you can wait when the server goes down before you mark it as down, so that no incoming request is affected? Okay. So that's all about, like, if you click on next, I think that's it. You configure the listener, and then you click create. Okay. Now let me go back to the already a load balancer created, so I can make it a conversation much more lively. Okay. So I've already created a load balancer here. I'm going to take this load balancer. Okay, maybe I think let me try one more. I think I have it here, which is my web application one. So this is the URL of the I'm using the IP address of it. So I think I'm just going to show you the quickly, if you can see, can you see my screen which says that web server 2 running, Jason?
Yes, I can see it.
Okay. So I think you can see here, like, it's going in. If I refresh right now, it goes to the web server 1. So it is using a round robin process. Okay. So basically what it's doing is it going between web server 1 and web server 2. What I'm going to do is I'm going to go and manually shut down the web server 1. Okay. And you can see that the web server is here. I'm going to bring it down. I'm just going to stop it. I'm not going to do anything. Think about this, like, the incident which I'm mimicking here is things went bad with the server, and server automatically went down. Okay. While it is doing, I'll go back to the a different networking side of the fence and see what does the load balancer do automatically. If you look at it, it is already declaring a warning from the health check. Okay, it says something is wrong right now. Let me go deeper into that. Now it says it's critical. The backend is already one is down. It's marked down. So let's go to the backends now, see what it does. Like, if you look at it, it has backend marked as 2, and it's critical because right now is one of the backends is automatically down. It's not servicing at all. Connection failed. Okay, so it's already marked it. So any incoming request now coming in will never go to web server 1. So I'll show you that in an example here. So if you click here right now, it's only going to web server 2. If I refresh it, no matter how many times I try, it is not even routing to that. It has marked it down. Okay. Now, the other thing which I talked about a little bit in this, the health check, right, which I showed you also, right? See if I've done it it's like interval is 3,000 milliseconds and the timeout is 2,000 milliseconds. Okay. I think the last thing quickly I want to touch upon is the network command center, and I'll stop. Before I do that, I think I want to have one more question from Jason. Jason, why is load balancer become so popular in today's industry because of the web application, especially when the cloud deployments are done?
Yeah, I mean, what I've seen here with a couple of customers I cover, the primary reason that they're considering load balancers is going to be resiliency and performance, right? Especially for workloads that are business critical, whether it's where your shopping cart runs, whether it's where you generate new leads, whether it's, an internal application that's running your warehouse. A load balancer is going to give you, two benefits for workloads that can use a load balancer. And we're primarily talking about stateless, workloads. We're not talking about oftentimes third-party products that you buy off the shelf. Those don't always work with load balancers as well. But for those stateless ones, a load balancer is going to allow you to fail over. Now, this could be a failover if something breaks in the middle of the night. This could be a failover if you've got a planned outage and you need to upgrade something and you fail the workload to one side and then fail it to the other. So think like a blue-green deployment if you're a developer, or if you just need to do a rolling upgrade to your environment. Load balancers can be used for that. Performance is the other thing that load balancer is going to give you, right? It's going to be able to spread out that workload that's coming into your environment across multiple instances, whether that's, 2 Linux servers, facilitating a simple website, or maybe you've got a microservice deployed across multiple pods and nodes within Kubernetes, and you've got hundreds, if not thousands of these picking up the workload. A load balancer is going to provide you all the smarts, all the routing, all that load distribution, so that, again, your users have a good user experience when they're being distributed across your environment. We've got 2 different load balancers. We've got one that's for application web-focused type workloads that runs at a layer 7. And it's going to provide you all the goodies that you would expect out of that layer 7 traffic and being able to fail things over and have health checks. We've also got an ultra-fast layer 2, layer 3 network load balancer. And that's something you might put in front of, say, your Palo Alto firewalls for internet egress and ingress to provide you failover between multiple instances of your firewall, or whatever your internet in and out is going to be for your VCN.
Perfect. Thank you, Jason. And just to close out, one of the things which I want to cover here is the network command center. I let you guys to go play around with it. The network command center provides you a view about how is your connectivity. You can certainly take a look at network visualizer and see that, how is my security connectivity from within the compartments work on, if I'm pretty sure a lot more customers have networking teams, like enterprise applications team, and you do not know how the network admin has created your structure. What is the security policies? Yes, a security list is attached to that, and you certainly can do that. If you look at it, you can see the VCN routing map. You can also look at the security side of the fence. Those are the 2 important perspectives. It provides you the visualizer so that you can certainly easy to visualize, okay, the private subnet is talking to this NAT gateway, and the public subnet is talking to the internet gateway. From a security perspective, we can also showcase what are the security list each subnet is using, and that visual connectivity provides you a lot more easy to debug it. If some traffic is not coming in, to ask for the network admin, hey, can you please check the security list? My traffic on this port is not been coming in, and you can easily debug it much faster. Okay. The other things in network visualizer also provides you, if you're deploying to the multiple regions and you want to say the inter-regency latency, you can certainly do that. Oracle publishes this, you can gather it in real time. What is the latency between the 2 regions? And last but the least, I think you can also certainly do that if you want to do that network path analysis I already talked about. Any questions before I start? I end the demonstration here, but I'll open it for Q&A so that you can, if you have any questions, please post it in the Q&A, as well as you can also open it for I don't know, Renu, can the customers have a live questions?
No, they'll have to put their questions in Q&A. You can read out those questions loud if you want. Perfect. And answer them live. You want to go to the Q&A panel, Anand?
Yeah, I see the 4 or 5 are open right now. as we do not get on-premise having the CPE to test it. Like, we do not get an on-premise having a CPE to test it. Jason, Lynn, do you want to take that? The user is asking, we do not get an on-premise having a CPE to test for the connectivity from on-prem world to the OCI.
That's a good one. Assuming they don't have a test, router sitting around. We've had customers that also test things like VPNs using software-based routers. I think Libra is one that I've seen customers use in the past where they need to do testing on a VPN with its failover or IPsec. They don't have a router sitting around, so they spin up a virtual on a VM and then do the setup from there.
Okay. The other one is how to count the number of WAF and load balancers needed or references. I'll take that, and Jason, you can back me up if you want to add more. Like, usually that we normally the standard recommendation is every web application front end with a load balancer, and with a WAF, like, front ending the load balancer. Okay, that's the normal recommendation.
Absolutely.
And the other one is if the fast connect is used by the application to access the database that are in OCI, I'm assuming this deployment is basically you have an application in on-prem world and you are having a database in OCI region, and you can certainly do that with a fast connect. Provides you that 10 Gbps speed and connectivity. You can certainly do that with an application being hosted. This is an hybrid model, right, where you have an on-prem, and that's what I think most customers are doing right now with their application in Azure and databases in OCI. That's a very classic architecture. They're using it with an interconnect between Azure and then OCI. You can certainly do that with fast connect being with the connectivity from an on-prem world to the OCI.
Yeah, I mean, I'd add one thing to that. As you're thinking about fast connect, that high-speed connectivity that is a 1 gig, 110 or 100 gig links, that is both from on-premise to OCI and is also the concept of from OCI to Azure. So you've got options, and you can do both. And I've got customers that absolutely do both, where they've got part of the workload on premise, whether that's just the DevOps portion, Oracle on Oracle. Of course, we host the Oracle databases, and they have a front end on Azure, and they're all connected via individual fast connects. Generally redundant, but fast connects for on premise, fast connects to Azure, and just have the whole hybrid environment set up that way.
And the other question is, does OCI provide SSL certificates, especially for the load balancer?
Yes, I mean, we've got certificate services, and customers can bring their certificates as well and put them on our application load balancer. Absolutely.
I'll take one last one. Are there any customers using the SD-WAN and /Telari with OCI? I think we need to table it. I do not know on my top of my head right now.
Yeah, Nanda, sorry, that one I don't have as well. I haven't run across a customer yet that have had the opportunity to work on that.
Okay, so I think with that, I think thank you for your questions. I think Renu, back to you for the poll.
Thank you, Anand. Thank you, Jason and Lynn. For questions like these and for other questions which did not get answered, please feel free to send an email to the alias that I put in chat. It's personaltrainers_us@oracle.com. And there's a team watching out that alias, so we'll be more than happy to answer your questions there. We have time limitation here today, so we'll not be able to address all the questions. But thank you so much for joining the session. And Anand, Len, and Jason, that was a great session. So I really appreciate your time and help. I hope everyone enjoyed this session. Now it's time for 2 quick polls. For the first one, please let us know how we are doing. So we need your feedback to continue improving our sessions. So on a scale of 1 to 10, where 10 is excellent and 1 is really bad, how likely are you to recommend this webinar to your colleagues and friends? Please remember that your feedback is very important for us. So let us know how we are doing. And you can also tell us how we can improve our sessions. So if you take a moment to answer this poll, that'll be good. Thanks, everyone. And we can move on to the next poll. And that'll help us identify the topics you would like us to cover in these series moving forward. So select the topics that you're more interested in, and based on your feedback, we can add sessions on those topics as well. So look forward to see you again on April 18th for our next session. The topic will be You're in the Cloud, Now What? And you can find the details on our Day One and Beyond page, which I will put the link right here. And while you're here, I would also like to tell you about another live hands-on workshop that we are starting. You'll find the link on the same page. With that, thanks again for joining us. See you all next time. Have a great day, everyone.